Can we start now? Yeah.
So, sir, on
Thank you.
42 participants are there. Shall I start?
Uh, yes, ma'am. We
Okay.
can start. Yeah, yeah.
Okay. Okay.
Six,
Thank you so much, sir.
six to five I get. Yeah.
Yeah. Thank you, sir. So, good evening, everyone. I'm back for that second day session. As per the schedule, today I'm going to discuss reliability and normality. So, I'm sharing my screen first. So, as I'll share my screen, I would be unable to see anyone. So, I request James sir. Good evening, James sir. So, I request any one of you, please tell me whether my screen is visible or not.
Not now, ma'am.
Okay.
Now visible.
Yeah. Are you able to see PPT?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes,
Thank you
ma'am.
so much. Thank you, sir. Thank you, everyone. So, yesterday I was discussing about the basics of SPSS. Today I am going to discuss about the second part or the second thing, that is reliability and normality of the data. So, before that, Ajay sir, I think I have shared the Excel sheet with you. I request you please share that sheet with the participants in the WhatsApp group.
Yes, ma'am. Sure.
Okay, thank you so much, sir. So today we will work on a data sheet, but before working on that sheet, firstly today I'll explain you the concept of normality and reliability. So the agenda of the day is I'm going to discuss the meaning of reliability, the methods of reliability, normality concept, and the types of methods which we are using to check the normality of our variable. So before going in these things, first thing is generally whenever we are developing any scale means any questionnaire or any instrument. So whenever I'll say scale, so the meaning of that is questionnaire or instrument. So for our research study purpose, many are times what we do, we are developing any questionnaire. So whether that questionnaire is a reliable one or not, we need to test that. So for that, we need to understand the concept of reliability. So today I'll discuss reliability in the four contexts. First one is, what is reliability? So reliability is the measure of consistency. Means whenever we are interested to check whether the particular scale is consistent or not, we will go or we will look for the methods of reliability. Meaning is that, means if I will use same scale or same instrument or same questionnaire again and again on the different samples, whether the scale will give us same result or not, means whether that scale is consistent or not, whether the questionnaire is consistent or not, that we are interested to know. So that we are checking with the help of methods of reliability. So this is the meaning of the reliability. Now, second thing is when we will go for checking of the reliability. So, whenever we have a variable which is we have measured on the Likert scale or any non-Likert scale, in that case we can go for the reliability testing. So, say for example, I have developed a questionnaire to check the customer satisfaction. I have made a scale of questionnaire. I have made a scale of customer satisfaction. In that, suppose I have taken total 20 statements on a 5-point Likert scale. So that way I can say that the construct is the customer satisfaction. And for that construct, because customer satisfaction is a construct which is a qualitative in nature, means I cannot say satisfaction would be 1 liter, 2 liter, 1.5 liter or something like that. So for that, what we are doing, we have taken certain statements, and with the help of those statements, we are trying to understand whether the customers are satisfied whatever services or products we are providing to them. So for example, I have written, suppose I am teaching here, this is the workshop I am taking here. I want to know whatever I am delivering through this workshop, whether my participants are satisfied with this, the things I am discussing in the session or not. So maybe possible I have made my first statement, that is, I am satisfied with the delivery of the content of the by the expert. This is the first statement I have given here. So might be possible I am asking you strongly agree. These are the 5 things I have, these are the 5 options I have given to you. Strongly agree, agree, neutral, disagree, and strongly disagree. Now, according to your level of satisfaction, you will mark whether you are satisfied with this particular statement, whether you are agreed with this particular statement, or you are not disagreed with this particular agreement. So likewise, you will give your opinion for this particular statement. And that way, I'll collect the data for all the statements I have written on this particular questionnaire. And that way, this will become the construct for the customer satisfaction. So now, for example, I have asked from the respondent or I have asked from the participants of this particular workshop, and I have developed a question, or I have noted down the 20 questions in that particular questionnaire. Now, the same questionnaire, if I'm using on the participants of some different workshop, and that way, if I am getting the consistent results, so that way I can say this particular questionnaire is a reliable one. So whenever we have Likert type of questionnaire or even the non-Likert type of questionnaire also, in both the cases, we can go for the reliability testing or reliability checking. Then question comes where we need to apply this reliability. So first thing, if we are using any existing scale, say for example, there is a scale, maybe you have heard about Seroquel scale. Seroquel service quality scale is there. So if I'm using the same scale which is already developed by the Parsuram and his colleagues, so if I'm using that particular scale, so in that case also I need to check the reliability of the scale. Already it is done by the Parsuram and their colleagues, but thing is, if I'm using that scale today in the present scenario, still I need to check its reliability. So first thing, if we are using the existing scale, in that case, we need to check the reliability. Second case, when we are developing our own scale. So for own structured scale also, you need to always check the reliability, and then we will say that this particular scale is reliable scale or not. So either we are using the existing scale which is already developed by someone else, or we are trying to develop our own scale. In that case also, we will check the reliability of the scale. Last thing is how, means how we are going to check the reliability. So the same answer is very simple. There are various methods available for reliability. Using those methods, we can check the reliability. So this way, this is the concept of reliability. So I think I'm able to make the clarification about the reliability. Am I clear on this particular slide? Can anyone tell me? Am I okay? Is it okay? Yeah.
Yes.
Okay. Thank you, everyone. So now we are moving towards types of reliability. So there are 2 types of reliability. The very first one is the stability reliability, and second one is the internal consistency reliability. So whenever we are checking that when we can use the same scale on the different samples and we are getting the same results or not. So such kind of scale or such kind of reliability is known as the stability reliability. Internal consistency reliability meaning is whatever the items I am taking on a scale, whether they are internally linked with each other or not, whether they are internally consistent with each other or not. So such kind of reliability is known as internal consistency reliability. Now, talking about the methods of reliability. So you can see here, I have mentioned there are total 4 methods available to test the reliability of any particular scale or questionnaire. The first one is the test-retest reliability, then parallel form reliability, then split half reliability, and lastly, internal consistency reliability. So first 2, that is test-retest and the parallel form. These 2 reliability we can keep under the stability type of reliability. So we will see all 4 reliability one by one here. Firstly, I will talk about test-retest reliability. In this particular slide, you can see the conceptual part, that is the theoretical part of test-retest reliability is written. I have converted this concept into the diagram form, and from this diagram, I think we can easily understand the meaning of test and retest, test retest reliability. So here you can see, say for example, I have any particular test or I have any particular scale or questionnaire available with me. So I am administering or I am using that particular test or scale on the same group of the respondent, keeping in mind that whenever I'll conduct this test, in those two tests, there should be a gap of at least 6 months. Approximate 6 months means when the sufficient gap we are keeping in the conduction of the same test on the same group 2 times. So that way we need to collect the scores of the respondents. Say for example, in a test there are 10 questions. I have asked those 10 questions from the respondents. Suppose I have 60 respondents available to me. So I have asked them to give your responses. I have collected their scores, whatever responses they have given, that I have collected. Now, after a sufficient large time, or I think we can say when we have a sufficient time on, we can say that now I think respondents will forget, have been forget whatever I have discussed previously. So again, I will administer the same test on the same group of people after a particular time period. And in that, again, I'll ask the same 10 questions to the 60 respondents, and again, I'll collect the score or their responses. So that way means same test I'm conducting 2 times on the same group of respondents, keeping in mind that the time frame should be the approximately a large enough time gap should be there in between these 2 conducts. That way we need to collect the responses of the respondents, and then we need to find the coefficient of correlation between the responses of the respondents. And if suppose we are getting the coefficient of correlation value greater than 0.7, so that way I can conclude this thing that my scale, my test or my questionnaire or my instrument is reliable one. So I think, am I clear on test reliability?
Yes, ma'am.
Yeah, thank you, ma'am. Now, talking about parallel forms reliability. So, again, for this, I have taken one example, and that you can see here with the help of diagram, I'm explaining you. Here, suppose you have a test or you have a questionnaire available to you. You have, what you have done, you have divided it into the 2 parts. First part I have given to the first group. Second part I have given to the, again, the same group. Means what I did, I have converted or I have divided my questionnaire into 2 parts, and I have given both the parts to the same group of respondents, keeping in mind that the conduction of the test would be, there would be a short span of time would be there in conduction of these 2 parts. So that way I need to collect the scores of the respondents, and then we need to find the coefficient of correlation. And if coefficient of correlation is greater than 0.7, so we can conclude this thing that the scale or the instrument is the reliable one. Is it clear to everyone, the parallel form reliability?
Yes, ma'am.
Yes, ma'am. Okay, thank you everyone. Talking about split half reliability. In split half reliability, rather than dividing the questionnaire into 2 parts, we are dividing the number of respondents into 2 groups. One group, suppose I have a 60 participants, so I have kept 30 in a one group and remaining 30 in a second group, and I have given both the groups the same questionnaire or the same test at the same period of time, and then I have collected their scores, and then I have calculated the coefficient of correlation. And again, if the coefficient of correlation is greater than 0.7, I can say this thing that the scale is the reliable one. So I think, am I clear on this?
Yes, ma'am.
Yes, ma'am. Okay, ma'am. Thank you. Lastly, the internal consistency reliability. This is the important one because in most of the cases we are calculating or we are finding the internal consistency. So here you can see generally it is refers to the degree of homogeneity of items in any instrument or any scale. So say for example, I have made a scale of customer satisfaction. So in that I have kept certain items, I have kept their certain statements. So I want to find the homogeneity in the items. So internal consistency is meaning how the items are correlated to each other. That is the internal consistency. So it tells us about up to what extent a test is internally consistent, or to what extent there is a good amount of balance or correlation between the indicators or dimensions of the constructs. So just now I just said that customer satisfaction can be a construct. So to measure that construct, maybe I have kept 20 statements in my questionnaire. So now how those items or how those questions are correlated to each other, that I am interested to know, and this is known as internal consistency. So here I have written one example. Say for example, we want to, or if we have a scale of the motivation. So the scale of, so if I scale on motivation, we can say that a scale of motivation is good at measuring in true motivation level among the subjects. We can say the reliability of that scale is high. Means whenever we have any scale of any particular construct, if its reliability is high, so we can say that that particular scale is measuring that particular construct in a better manner. So say for example, this is the motivation construct, and for that suppose we have taken 10 items, x1, x2, x3 and up to x10. These are the indicators, dimensions, items or questions we have taken to measure the motivation, because motivation is a qualitative construct or qualitative variable, latent variable it is. So to measure it, we cannot say, like for example, I can again take the example of yesterday's class. Yesterday I said if I want to go in a market and if I want to buy suppose water, so I can say I need to have 1 liter bottle of water, right? So that way it is quite easy for me to buy such kind of things, but if or to measure such kind of things. But in social science field, if we are measuring such kind of variables whose units we are not knowing, so in that case, to measure them, it is quite a challenging task for us. So for example, motivation is again a qualitative phenomena. So to understand this, what we can say, suppose we have taken 10 items or 10 questions. So if these 10 questions are sufficiently or fairly correlated to each other, in that way we can say these statements are truly measuring the motivation of any particular person. So I think, am I clear to everyone?
Yes, ma'am. Yes, ma'am.
Okay, thank you so much. Now, talking about again internal consistency. So in statistics or in SPSS generally, Cronbach's alpha. Maybe you have heard about this particular term. Cronbach's alpha we are using to find or to calculate or to measure the internal consistency of any particular scale. This particular term was given by the after the name of the American psychologist, that is Lee Cronbach. Means this particular person, this particular psychologist has introduced this particular term, Cronbach's alpha, and after his name, he has given that entity the name as Cronbach's alpha. Means there, this is the alpha, and after his name, this particular thing has become Cronbach's alpha. So it is a measure of internal item reliability or internal consistency. Generally, we can say it's a coefficient which gives us the measures of internal consistency of any test or of any particular scale. So that means how fairly the items on that particular scale are correlated to each other. We are trying to measure that thing using the Cronbach's alpha. So this particular Cronbach's alpha can also be used for the continuous scale variable, and also we can use it for the dichotomous scale variables. So may I shift to the next slide? Is it clear to everyone?
Yes, ma'am.
Yeah. Now, talking about how we can calculate Cronbach's alpha. So here you can see I have written two methods. One is the variance method and second one is the correlation method. And in those methods, the formulas are already given. So using this formula, we should have the values of these all entities or notations, and that way we can calculate the value of Cronbach's alpha. But I think we have software. With the help of software, we can easily calculate these Cronbach's alpha values. So I'm not going much into the calculation or the manual calculation part. Now we are directly coming to the interpretation part of the Cronbach's alpha. So I will read this particular table from the bottom. I'll come from bottom to top. So here you can see when the alpha value is less than 0.5, that way we can say the reliability of our scale is unacceptable. If alpha value is less than 0.5, we will not going to accept the scale, or we can say that the scale is not consistent. If alpha value lies in between 0.5 to 0.6, we can say it's a poor, or the scale has the poor reliability. If alpha lies in between 0.6 to 0.7, we can call it as a questionable reliability. But if alpha is in between 0.7 to 0.8, we can say we are accept, or we can accept the scale, or we can say that the reliability is acceptable for the particular scale. If alpha value is lying in between 0.8 to 0.9, we can say that scale has a good reliability. And when alpha value is greater than 0.9, so we can say the reliability is excellent. But if we are getting alpha value greater than 0.9, please everyone pay attention on this particular line. If we are getting alpha value greater than 0.9, this is again a alarming situation for us, because alpha is what generally, I think I told you just, it is coefficient of correlation. And when the items are highly correlated to each other, that way we are getting the alpha value as 0.9. So that means it is indication that might be many of the question or some of the questions on the scale are maybe similar, or maybe taken maybe they are understand, maybe the respondents are understanding that these statements are similar, so that's why they are giving the same type of opinion for those questions. So that we need to identify, that we need to find out, because in the SPSS we can directly calculate the coefficient of correlation for whatever number of variables we are having. So that way we can cross check in which two variables there is a very high correlation is existing. If two variable or two statements are having the very high coefficient of correlation, that is 0.9 or more than 0.9, in that case we need to immediately drop one of the question. Means we need to decide upon which question we are having, or which will keep in the scale, and which question or item we are dropping from the scale. So this particular situation is known as the multicollinearity problem in statistics. So when two items are almost similar, or when two items are treated almost similar by the respondents, that way it is a chance that we are getting the alpha value very high. In that case, we need to immediately identify which two variables or which two statements are showing us the high correlation, and we need to drop one of the item from the scale. That way we can reduce the value of convex alpha. So I think, am I clear on this part?
Yes, ma'am.
To everyone?
Yes, ma'am.
Okay. Now, how we can apply convex alpha in SPSS? So I think rather just a minute. Apart from, yeah. So I think this is the process I have mentioned here. So rather than reading this process, I'll take you to the SPSS, and there I'll tell you how we can apply all these things. So after that, I'm coming to the next skill. This is already I discussed. Now, important thing, you can see here how we can improve the reliability coefficient for our scale. So there are certain methods available. With the help of that, we can improve the reliability coefficient of our scale. Means, for example, if we are getting the alpha value is 0.65, so we are knowing 0.65 is not acceptable value. We can say that that particular scale is not consistent. So if we want to improve the alpha value, so what methods we can practice, or what methods we can consider? The first one is we need to firstly diagnose. We need to firstly diagnose the missing values in the scale. Means we need to check upon this thing whether for any particular statements we are having any missing values. If so, suppose I have collected the responses of the 100 people. So in that case, might be possible there is one question which is unanswered by most of the respondents. So for example, for that question, I have got only suppose 50 responses out of 100 respondents. So that way, that is a question mark type of thing for me. So maybe I can drop that question from my scale, and then I'll be going of the reliability checking with the help of remaining number of items on my scale. So that we need to diagnose that how if any particular statement or question or item has so many missing values, we can drop it. Again, I'll tell you one thing here. Is that it is totally your decision, because you, being a researcher, would always be the answerable for each and every activity whatever you are carrying here. Suppose you are dropping any item, you need to write each and everything in your questionnaire paper, that because of this reason this particular items was dropped from the questionnaire, like that. So you need to mention the reason along with the thing that this particular item has been removed or dropped from the questionnaire because of so and so reason. Next, you need to diagnose on the scale, mean scale and the standard deviation scale. So for each and every item, when I'll tell you the reliability testing using that SPSS, so there we will get the mean of each and every item along with the standard deviation. So we need to diagnose that also. If there is some problematic situation, means suppose standard deviation is more than the mean value, so in that case we need to remove those particular items from the questionnaire. Then you need to diagnose on the item total correlation. So item total correlation value, again, if there is some issue with the item total correlation, I'll tell you in the coming slide that what should be the acceptable value for item total correlation. So if that value or up to that value we are getting the item total correlation, we will accept that item, or we will keep that item in the scale, or else we will drop that particular item. Lastly, you need to check the ambiguity of the items or redundancy of the items. If any of the item is the ambiguous, that means to a particular item you have mentioned or question you have mentioned which is having two meanings, means you are taking it in other way and maybe some other one is taking in some other sense. So that way you need to keep a close watch on such type of questions. Suggestive one is you can drop that, or you can meet to any expert and ask them to reframe that question. And if redundancy in the question is there, that means repetition is there in the questionnaire, maybe same type of question we are keeping 2 times in a questionnaire, so that can also trouble us for getting the right reliability value. So in that case you need to remove the redundant items from the questionnaire. So these are the certain way which can help us out to improve the reliability coefficient of our scale. So am I clear on this slide?
Yes, ma'am.
Okay, thank you, sir. Now, the thing I was talking about, how we can improve the convex alpha. So here you can see, to improve reliability, we can delete few items, but while deleting, we need to keep few criteria in our mind. The very first one is, first delete those items whose item total correlation is negative. Means we will look at the item total correlation column, and for any item, if this value is negative, so we will immediately drop those items from the questionnaire. Then after that, if means, for example, if we are adopting the first thing and maybe it has improved the coefficient of correlation and we are satisfied that particular value, so maybe we do not need to go for the second process. But still you need to work upon, if still you want to improve your coefficient of correlation value or the convex alpha value, so what you can do, then you can delete the items which are having the less than 0.3 item total correlation. Generally you can see I have written two things here, 0.2 and 0.3. So depending, generally suggestive one is 0.3, but still, because if suppose might be possible most of the items are dropped, if suppose you have taken 20 items and 7 to 8 items you have dropped to improve your reliability, so that is again a question mark type of thing. So maybe in that case you can go with 0.2 also. So if item total correlation value is less than 0.2, so you can remove those items to improve the convex alpha value. So we can say generally accepted item total correlation is 0.3 or above 0.3, but still we can go with the 0.2 also. So that way, using these particular methods, we can improve the convex alpha value. So till here, I think I have tried to prepare the base for the theoretical base of the reliability. So I think everyone is clear till this particular point or slide.
Yes.
Yes.
Okay,
Ma'am.
thank you. Okay, thank you, sir. So now I'll take you on WhatsApp. On just a minute. We need to open the. I think I have given you Excel sheet. Everyone has got it? I think Ajay sir has already shared the Excel sheet in the WhatsApp group. I hope everyone has received it.
Noted, ma'am.
Okay. So is it on WhatsApp group or not? Can anyone confirm me? Anyone?
Not yet, ma'am.
Okay. Ajay
Not
sir?
yet, ma'am.
Okay. Ajay sir, are you in a meeting? Because I have shared with sir only. Ajay sir, are you in meeting? Anyone from RFI is there in the meeting? Sir, will you please confirm this thing from Ajay sir? I have shared the Excel sheet with the sir. Maybe sir has forgot to share with the participants. So will you please ask him to share the sheet with the participants? I'm not there in a group, sir. So will you ping me on WhatsApp? You have my WhatsApp number? Sir, have you got my number? Sir, please share, ping me on WhatsApp. I'll share the sheet along with you. Okay. Thank you, sir. I hope you have received, sir. It is showing me double tick, blue tick. Have you received it? Okay, thank you so much. So I think participants, can anyone confirm me? Have you received it?
Yes, ma'am.
Ma'am.
Yeah,
Okay, thank you. Thank you so much, ma'am. So I expect from all of you, please download that file. Downloaded?
Yes.
Just a minute. Again, I need to share my screen. Can anyone tell me my screen is visible?
Yes, ma'am, it's visible.
Okay, thank you. So here you can see, I have opened a fresh SPSS file here. Now I tell you firstly how to import file in SPSS. So everyone be ready and look at my screen first, and then I'll give you 2 minutes to import your file in your SPSS if you are working along with me. So for opening a file in SPSS or for importing the data in SPSS, you need to go to the file menu. Then you need to go to open, and then you need to select data. Again, I'm repeating, go to file menu, select open, and then go to data and click here on data. Done? Anyone is working along with me?
Yes, ma'am.
Okay. So, sir, are you here till here along with me?
Yes.
Okay, thank you. So now here you need to see, look in means you need to give the location from where you want to import the data, or wherever you want to pick the file. So here I am giving the location of my file. My file is in the where is the drive? D drive. Yes. So now I have opened the specific folder where my file is situated. So I think my file is in the Excel form. So you can see no Excel file is visible here. So what you need to do, you need to come here in the files of type, and you need to share, or you need to change the type as Excel. So here you need to select on Excel. Once you will do so, all the related file will be visible to you here. So here my file is the customer satisfaction towards restaurants. So that I have selected here, and then I need to only click here on the open. Is it done? Everyone is with me?
Yes, ma'am.
Okay. So I have clicked here on the open. Now it is asking me to read the file in this particular format, and this is the what I can say, this is the A1 to AE122 is the range of the file. So that way these cells will cover the data of my file. So I do not need to do anything here except clicking on the OK. So once I'll click on the OK button, you would be able to see the data is imported by SPSS in the data view of this particular file. I think it is visible to each and every one of you.
Yes, ma'am. It's
31 questions I have imported here, and total how many respondents data it is? 121. So that way you can see, means in SPSS the questions or the variables are coming according to the column, and responses or respondents values are coming in the rows form. So this is that way we have firstly taken out or brought the data here in the SPSS. So I think till here everyone is with me. May I proceed further?
Yes, ma'am.
Okay.
Yes, ma'am.
Now you need to click on the analyze menu. Done. Then you need to select scale and then reliability analysis. Go to analyze, then select scale and then reliability analysis. So now I'm clicking on the reliability analysis. So this is the scale of the customer satisfaction, and nothing means no, what I can say, descriptive variable or demographic variable I have not taken on in this particular file. So that means all the statements I have taken here, these are the Likert scale questions I have. Now I'm selecting all the questions here. What I did, from my keyboard I have pressed here Control A. So all the questions have selected by me in one go. Now I need to shift all those questions in the items box using this arrow button. So I think it is done. Anyone who is performing
yes,
along with
ma'am.
me?
Yes,
Yeah.
ma'am.
Yes.
Okay.
Yes.
Now you can click here on statistics button. So I have clicked on the statistics button here. So now I think we are able to see the reliability analysis statistics dialog box. Now under the descriptives for, you need to click on item, scale and scale if item deleted. Done. All three from the descriptives for box you need to check. Done.
Yes, ma'am. Done.
Now you need to only press continue to get the output, and you would be back on the same dialog box. Here you can see model by default is alpha. So yes, we want to calculate the coefficient Cronbach's alpha value only. So we will go with this, and we will only press on OK to generate the output. I hope output window is visible to everyone. Is it visible or not?
Yes, ma'am. It's visible.
Yeah. Yeah, thank you. So now you can see the very first table is the case processing summary table. Here you can see cases. Valid cases are 121. So that way we are taking 100%. Excluded are nothing because there is no missing value. So that way you can see total cases are 121. Now coming to the second table, that is the reliability statistics. It is giving us the Cronbach's alpha value. For the 31 items or 31 statements, we are getting Cronbach's alpha as 0.672. So can I say I am going to accept the scale on the consistency parameter? Can I say this? I think I have.
Yes, ma'am.
Okay.
Yes.
I think I have shown. Okay. Thank you, sir. I think I have shown you the interpretation part of the alpha, Cronbach's alpha. So can I say this is the acceptable value? Anyone else?
Yes.
Okay. Anyone else? I think two people told me yes. Anyone else?
Ma'am, no.
Okay. Fine. Sorry. I think when I have just a minute, I need to show you again. I think when we were discussing the reliability, I have shown you this
No, ma'am,
particular.
it's not.
Yes, yes,
Questionable reliability.
yes. It's a questionable reliability. It should be greater 0.7 or greater than 0.7.
Yes, ma'am.
So till here, we are not going to accept the scale with that we will say that particular reliability are not considered. Got it? Everyone is understanding?
Yes, ma'am.
Yes, ma'am.
So that is why, just a minute, I need to open the output window. Yeah. So on the basis of that, I'll say that this is a questionable reliability. That means if I will code this reliability in my research paper, so the reviewer will ask me that why why on the what basis I'm saying this thing that my scale is consistent scale. So this is not going to accept in any good journal. So in that means now what I need to do, I need to improve it. So I'll check the other things, how I can improve it. So you can see in the next table, here we are getting all the questions listed. Along with that, we are getting the mean value, and then we are getting the standard deviation value. And for each statement, you can see here, for each and every item, we are having 121 responses as per the response sample size. So that way, nothing is missing for any particular question. Now you can check upon the mean value and the standard deviation value. So we can say the mean value and the standard deviation, after looking at the mean value and the standard deviation value, I can say that the standard deviation is always less than here for each and every item on the when I'm comparing it with the mean value. So that way, I think I'm not finding anything here. I'm going to the next table. That is the item total statistics table. Here, I think I have told you, you need to check upon the item total correlation. So firstly, I will read here for question number 1. So I'm reading only for the first item. Please everyone pay attention or listen. For question number 1, the first thing is scale mean if item is deleted. Means if I will delete the question number 1 from my scale, so the scale mean would be 96.74. Similarly, if I will delete this particular item, then the scale variance will become 147.242. Then coming to the item total correlation. So it is 0.030. This is the Cronbach's alpha value, means this is the improvement or this is the impact of the Cronbach's alpha value if this particular item will be deleted. So I think presently alpha value is what? It is 0.672. So if I will delete the item number 1, so what will become? It will become 0.675. Clear? Means if you will drop the first item from your scale, so your Cronbach alpha means when you will again calculate the Cronbach alpha after dropping your question number 1, it will become 0.675. Okay, is it clear to everyone?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Now, I think I have told you we need to closely watch the item total correlation column. So here, firstly, we need to find for any of the item whether I am getting the negative value or not. So I am cross-checking it. I think you can see here for 2 items, question number 23 and question number 24, we are getting the item total correlation as minus 0.110 and minus 0.102, right?
Yes, ma'am.
I
Yes,
think
ma'am.
everyone is getting who are performing along with me, right?
Yes,
Ma'am,
ma'am.
one doubt, ma'am, if I have my own data, so I can work on that data too?
Up to you, ma'am. After the class, you can work also. Firstly, you are understanding, so I think you need to understand along with me with the help of this data. So that way you can interpret things fastly. Otherwise,
Okay,
you will
ma'am.
get puzzled with your data because I'm dealing with this firstly.
Okay, ma'am.
Okay. So these 2 figures are negative figures. So that means this is the indication. Firstly, I need to drop question number 23 and 24, and then I'll check the other parameters. So again, what I need to do, you need to use this particular handle. This is the shortcut for accessing the recently used tools. So you can see reliability analysis is coming here. I'm clicking on this. So same window will open. Open. Everyone has opened it. Those who are performing. Yes. Now from this question number 23 and question number 24, I am taking back to the left box. You can see now we have the remaining questions available here at the items box. So you do not need to do anything except pressing on OK. Can anyone tell me improvement can be seen or not?
Yes, ma'am.
Yes. So you can see now from 0.672 it is coming as 0.701, right?
Yes.
So that is now it is acceptable one. And that way in this process we have removed the 2 items. So now we need to write down this thing in our research paper, that to improve the reliability or the coefficient or the Cronbach's alpha value, 2 items whose item total correlation was negative were dropped from the questionnaire, and thus we have got the Cronbach's alpha as 0.701. Is it clear?
Yes, ma'am.
Okay. So this is the process of improving the Cronbach alpha value. So till here, I think any of the issues you have, you can ask me. Then I'll move for the second half for the normality. Any question so far?
Ma'am, I have a question.
Yes, sir.
Ma'am, if we drop these 2 questions, then what is the reason we have to quote in the interpretation?
I just told you, sir, as I think the previously your Cronbach's alpha value was 0.672, which is not acceptable usually. I think when you will, whenever you will read some research papers, you will see generally the quoted or the cited or the mentioned Cronbach's alpha value is 0.7 or more than 0.7. So for any of the study, generally it is suggested the Cronbach's alpha should be greater than 0.7 for your skill which you are using to write any research paper. So if it is less than 0.7, so I think there is no use to write that value in a research paper. So it is quite clear you need to improve it. So you can write this thing with the 38 statements or with the 31, with the 31 items, the reported Cronbach's alpha value was the 6.672, which is not acceptable. So to improve it, 2 questions, question number 23 and question number 24, whose item total correlation was less than or was negative, were dropped from the questionnaire, and then on the remaining 29 items, the same process would be performed, and that way the received or obtained Cronbach's alpha value is 0.701, which is acceptable one and which is being reported here in the question paper.
Okay, ma'am. Sure.
So anything else? So I think, shall I move for the second half of the day, normality?
Yes, ma'am.
Yes, ma'am.
Okay. So I think again I have switched to the PPTs part. Can anyone confirm me whether the PPTs are visible or not?
Yes, ma'am, it's visible.
Okay, thank you so much, ma'am. So here, whenever we are, I think yesterday I have discussed about the parametric test. Can anyone recall and tell me what do you mean by parametric test?
The test in which we use quantitative data.
Yes, very good, ma'am. Very good. One more thing I have told yesterday. Can anyone tell me? I told one more thing yesterday. Can anyone tell me?
Normal distribution of data.
Yes, thank you so much, sir. Means whenever we are bothering about the normality of our variables, whenever we are bothering about the normal distribution of our data, that means whenever we are performing the parametric test, that means you must be bothered about the normality of your data or of your variables. So you need to check whether your variable or your data is following normal distribution or not. So there are certain characteristics or features of normal distribution. You can see here most of the parametric, it is written here, I think most of the parametric tests require that the assumption of normality be met, because when from tomorrow's only we are going to start with the parametric test. So I'll discuss all these things, or I will discuss the assumptions of each and every test. So in those assumptions, generally we need to check the normality of our variable. So normality means that the distribution of the test is normally distributed with the mean 0 and the standard deviation 1, and a symmetric bell-shaped curve is obtained. So means any data which we are plotting on a graph, maybe with the help of the histogram or etc., and then we are putting the bell-shaped curve on that data. If the mean of that data is 0 and the standard deviation of the data is 1, we can call that data is following the normal distribution. Apart from that, if we are getting the skewness value as 0, you can see here I have written some figures, some ranges. So do not pay attention right now on these things, because I'm talking about the standard normal distribution curve. And in practical life, I think it is very hard to get our data which is following all the features of standard normal distribution curve. Okay, so for the standard normal distribution curve, mean should be 0, standard deviation should be 1, skewness and kurtosis should be 0. Now, skewness means the measurement of asymmetry in the data. Means, I think those who have seen the bell-shaped curve, I think it is, you can see here, this is the bell-shaped curve. The second curve is the bell-shaped curve. So it can see 50% is data will lie at the left-hand side of the mean, and 50% data will lie at the right-hand side of the mean. So that way I can say this is the symmetrical data. But when there is some disturbance, means mean is here, and more than, you can see this particular shape. So here you can see more than half of your data is falling at the right hand side of your mean, and less than half of data is falling at the left hand side of your mean. So that way I can say this is the skewed data. This is the left skewed data. And when mean is falling at the right hand side, and that means we can say when less of the data is falling at the right hand side of the mean, mean, and the more than 50% data is falling at the left hand side of the mean, that way we can call it as a positively skewed data. Or when mean is less than median, median is less than mode, in that case, that way we can say that data is negatively skewed. Or when mean, median and mode, all three are equal, that way we can call it as symmetrical data. When mean is more to the median and median is more to the mode, that way we can call it as a positively skewed data. So skewness is the measurement of asymmetry in data. Similarly, kurtosis meaning whenever we are interested in measuring the peak of my well-shaped curve, whether this particular shape I'm getting, I think I'll show you, maybe it would be here. I need to show you the diagram, just a minute. Skewness is here? No. Maybe just a minute, I need to draw here a diagram. In Google Meet, I think I cannot use, just a minute. I'm using my Word file. I think you would be able to see a Word file.
Yes, madam.
Yes, ma'am.
Yeah. But I think here I think I need to use pen. Here I cannot draw anything. I think everyone is able to see.
Yes, ma'am.
Right. You can see only these two. I'm drawing a line here. We need to see the figures which I have made here at the right hand side. Just a minute. हाँ भैया जी Sorry, there was a call from the college. Just a minute. Where was I? I was on the pen. Here you can see. Now I think you can comparison. You can make comparison in the peak of these two graphs. In the first graph, you can see peak is very sharp. In the second graph, the peak is not much sharp. So when we are interested in doing the study of the peak of any graph, that way we are interested in the studying of the tail of the curve. So this type of study is known as, we are interested in knowing the kurtosis value of our data. Got it? Got it, everyone?
Yes, ma'am.
I think, am I audible, right?
Yes, ma'am.
Yes. So that way means on the basis of these features, we can say a particular variable is normally distributed or not normally distributed. Fine. Normality parameters is clear. Mean should be 0. Median standard deviation should be 1. Skewness and kurtosis should be 0. But in practical life, these figures are hardly to get. So that way we can say when mean, median and mode are equal for any data, we can say one feature is met of the normal distribution. Similarly, if the skewness is lie in between plus minus 2 and kurtosis lies in between plus minus 3, that way I can call that the variable is normally distributed. It is okay?
Yes, ma'am.
Yes. Now, how we can check normality of the data? So there are two methods, the numerical methods and the graphical methods. Under the numerical methods, we can keep skewness and the kurtosis indicators. Then we can keep the Kolmogorov-Smirnov test, and we can use the Shapiro-Wilks test to check the normality of the data. If we want to use some graphical methods, we can use the histogram, we can use the QQ plot, and we can also use the box plot. Now, I think histogram is much more easier to understand and clear to each one of us. Generally, whenever we are having the numeric data, whenever we are having the continuous scale data, we are making the histogram rather than going for some other types of graph. Because to check the normality of the continuous variable, one of the method is the histogram. So, with the help of the histogram, we can check whether the data is normally distributed or not. So here I have taken the example of some of the different types of histograms. So the very first graph you can see here, it is a skewed graph. It is showing us look for the other processes in the tail. Means when we can say if I will keep here the bell-shaped curve, I think that way you would be able to see the right tail would be greater than to the left tail. So that way I can say this is the rightly skewed data or positively skewed data, right? Right? Here in the second diagram, you can see where I am rotating my mouse. In this particular diagram, you can see that there are two peaks available. That means this is the data in which there are two peaks available. So this is the binomial distribution kind of data we are having. This is, we can say, this is a type of bell-shaped curve. This is the normal distribution curve. So means if I will keep the bell-shaped curve here, so I think that way I can say this particular data, for that data which I have made this histogram, that particular variable is normally distributed. This is clearly showing us that here if I'll keep the graph like this, it would be like this. So that way again I can say this is a right-tailed data, or this is the skewed data. And for this particular data, I can say it is not telling any type of distribution of the data to us. So with the help of histogram, we would be able to tell whether the variable or data follow the normal distribution curve or not. I think I'll show you in the SPSS. That way, I think it would be easier for you to understand. So you can see this is the histogram data. And on that data, if we are able to keep these bell-shaped curve, with the help of these bell-shaped curve, we can understand whether the data is normally distributed or not normally distributed. Second one is the QQ plot. So very first one you can see if the data points is following this trend line, means all the data points or all the values are falling along with this particular line. So that way I can conclude that the data is following normal distribution using QQ plot. This is the quantile plot. If data is like this, means when the data points are away from this particular trend line, So that way I can say that data is skewed. And when the points are taking curve at the right hand side, so we can say that the data is left skewed. When this curve is coming at the left side, so we can call it as a rightly skewed data. This is showing us that the thickness is more of the tails of this particular data, and this is showing that the thinness of the tails are more of the particular data. So with the help of the QQ plot also, we can conclude about the normality of our data. Now talking about box plot, it is the important measurement. It is tell us so many things. First thing you can see, with the help of box plot, with the help of box plot, you can see here the middle line is the median value. The middle line in the box is always telling us the median value. The lower wall of the box will tell us the first quartile. The upper box of the boxes tell us the third quartile. This is known as the lower whisker till this line. From here to here, this is the lower whisker, and from here to here, this is the upper whisker. If still some data points are exceeding these whiskers, so these are known as the outliers in the data. So these are the possible outliers, and if these outliers converted into the strict form in the SPSS, it is also shows. It also shows you the data in the asterisk form also. So asterisk means these are the significant outliers in the data. So those significant outliers should be dropped from the data if you want to get some good results from your data. So I think this is about the normal distribution. I think may I switch on the SPSS and we'll discuss how we can find all these things using these different methods. Conceptually, I think am I able to make you clear? What do you mean by this?
Yes, ma'am.
Yes, ma'am.
Okay. So I need to share one more. Just a minute. I need to share one more file with all of you. So I am presenting screen. Sir, from RFI, sir, are you here? Sir, I am just sharing one more file with you. Please share with the participants. Yeah. Sir, I have shared I think two files I have shared with you. Will you please share with the participants? Yeah. Okay, thank you, sir. Sir, will you please wait? I think I am sharing one more file. Yeah. I have got. Please, sir, I have shared. Thank you. So I am expecting those who are performing along with me, please open the employee database. I need to also open. Give me a second. I am also opening. I think I have stopped sharing my screen. No.
Yes,
My
ma'am.
screen. Yes, my screen is visible or not now?
Not specific.
Not yet, ma'am.
No, ma'am.
Ma'am, it's visible now.
Now it's visible.
Okay, thank you. So I have opened the employee data set here. Everyone please open it, the same data set. Now on this data set, we will check the normality of our variable. Firstly, we need to always keep in our mind whenever we are having the continuous scale variable, for that variable, we should have some bothering, or we should bother about the normality of a continuous scale variable. So here you can see so many variables, because these icons are telling us these are the continuous scale variable. These are the nominal scale variable and this is the ordinal scale variable. So suppose I am taking the salary variable, and for this variable I want to check whether the variable is normally distributed or not. So for that, what you need to do? Firstly, you need to go to the analyze menu. Then you need to go to the descriptive statistics. Then you need to select the explore. Again, I am repeating, go to the analyze menu, click on descriptive statistics, and then select explore. Done. May I click on explore? I think you are with me.
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. So I'm clicking on explore. So I think everyone would able to see here the explore dialog box, right? Is it
Yes,
visible?
ma'am.
Yes. From here, I am passing the current salary variable to the dependent list box. Done.
Yes, ma'am.
Now you need to click on the statistics button. So by default, descriptives is checked by the SPSS at the 95% level of confidence. So we will go with the selected options. You do not need to touch anything here. You need to only press continue. Then you need to click on the second button, that is the plots button. Done. Second, I think first button is you need to only press continue, and then you need to click on the plots button. Done.
Yes.
Yeah. Now here you can see at the left hand side, box plot option is given. In that, factor labels together, dependent together. So here we are going with the by default option, because we are not having any independent variable here. That is factor. Factor variable we do not have here. So we will go with the by default option. In the descriptive, there is stem and leaf is by default selected by SPSS. So stem and leaf is the very old method. We will go with the histogram. So you need to check on the histogram button, and then you need to click on the normality plots with tests. You need to click on this. So till here, I think everyone is with me. You need to go with the three things: factor labels together, histogram, and normality plots with tests. Till here, everyone is with me.
Yes, ma'am.
You need to press continue. You will be back on the same screen or the same dialog box. Now you can see here in the display, both option is selected. If not, so you need to check the, you need to click on the both option. That means it will give you the statistics along with the plots. Means both the things we are getting here. So you need to only press OK here. So I think, may I click on OK?
Yes, ma'am.
So once I'll click on OK, the output will be generated by SPSS. I hope the output window is visible to everyone.
Yes, ma'am.
Okay. So here you can check the current salary, total sample or total respondents were 474. Valid percent 100, no missing value. So that way total percent is 100%, and the total sample size is same as the capital N. This is the explanation of the first table. Now moving towards to the second table, descriptives table. So I think, may I discuss the second table? May I start discussing?
Sure, ma'am.
Yeah.
Yes, ma'am.
So for current salary variable, you can see the first thing is the mean value, which is $34,419.57. This is the mean salary of the data, because this is the data of the US company. So that way the salary is in the dollar form. Now, next one is 95% confidence interval for mean. Upper limit and the lower limit at the 95% confidence interval is given here. So that means if I'll pick the different sample from the same population, mean will lie in between these two ranges. Now 5% trimmed mean. That means if we will remove the outliers from the data, 5% from the upper side and 5% from the lower side, that way the mean value will become this. So you can check here, the actual mean value is 34,000 something and the trimmed mean value is 32,000 something. Why so it is? Because some of the observations, those are the treated as the outliers. Outliers are what? Can anyone tell me what do you mean by outliers? What are the outliers? Very good, ma'am. These are the extreme values. They can be the either side of the data. Say for example, what would be the mean for this data? 120, 130, 135. 135 divided by 5. So the mean would be 27. Yes or no? Please be interactive. I think it is difficult for teaching me. Means it is very difficult if I'm not getting any responses from the other side.
Yes, madam.
Yes.
Yes.
Okay, okay, thank you. So here you can see if I have taken 5 values of any data and these are the 5 figures, and if I have found the mean value, I think it is 27. So from this, you can clearly identify this thing. I can say 27 is not true because generally mean is what? It is the central value, it is the single value which represent the whole data set. So can I say that 27 is representing this data set? I think no. Yes.
No.
Yes,
ma'am.
because it is affected by the extreme value. Because involvement of this 120 to 120 has increased the mean value of this data. So that way, neither it is representing the lower data points, neither it is representing the higher data point of the data set, right? So that way, if outliers are present in the data, they can affect your results. So you have to be much conscious about the checking of the outliers in your data. Got it?
Yes, ma'am.
Yes, ma'am.
Yeah, just a minute. I need to come back to the same file. Yeah. So that way 5% trimmed mean meaning is it has removed 5% outlier from the upper side and 5% outlier from the lower side. And that way for the remaining data set, this was the calculated mean value. Now it is clear?
Ma'am.
Now median figure means it is the $28,875 is the median salary. Means this is the figure which divides the data into 2 equal parts. 50% of the employee of the organization will get salary from this less than from this figure, and 50% of the employee will get the salary from above from this particular figure. This is the interpretation of the median value, right? Variance is and the standard deviation are the indication of the variability in the data. So how much is the variance or spread in the data, that we will see with the help of this standard deviation. Minimum salary of this data set or the employee of a organization which is getting the minimum salaries. His salary is what? It is 15,750. The maximum salary of the organization is 1,35,000. Means there is a particular person who is getting this particular salary. Now the range is, it is the difference of maximum and the minimum value. So this is the range. Then interquartile range is the difference of the third quartile and the first quartile, which is 13,163. Skewness value is 2.125. Kurtosis value is 5.375. So from these two figures, because I told you these things when we were discussing about the normality of the data. So can anyone tell me, on the basis of these two figures, can I say that my data is normally distributed?
No.
Yes, thank you, ma'am. Because I told in the part of the description, in the theoretical part, I told you skewness is the plus minus 2. You know, if the value of the skewness falls in between plus minus 2, so that way I can say we are considering that data is approximately normally distributed. Similarly, if kurtosis is falling in between plus minus 3, I'll conclude that the data is approximately normally distributed. But neither of the skewness means neither of the figures are telling us that the data or the salary variable is following the normal distribution. Similarly, I told you one more characteristics when the mean and the standard, when the mean and the median and the mode, although it is not telling us mode, but we can say we can find the mode also. So if all these three figures are similar, that way I can say that the data follows the normal distribution. So from here we can conclude this thing, from this descriptive table I can conclude this thing, that variable current salary variable is not the normally distributed variable. But as you can remember, I have checked one more box there, that is the normality test. So for that, one more table is coming here, that is the test of normality. So here you can see two things are mentioned: Kolmogorov-Smirnov test and the Shapiro-Wilks test. Kolmogorov-Smirnov test and the Shapiro-Wilks test. So in that, which one we need to consider? Generally, when the sample size is less than 1000, we are going with the Shapiro-Wilks. When the sample size is sufficiently large, we will report the Kolmogorov-Smirnov test. So we have only 474 data set or the sample size available with us. So we will report Shapiro-Wilks test. So for this data, the significant or the p-value is 0.000. So the thumb rule, I think, have I discussed the thumb rule of the p-value yesterday? Yes, anyone, please?
No, ma'am.
Okay.
No, ma'am.
So, okay, thank you, sir. Thank you for confirmation. So if I have not discussed, today I'm telling you, if anyone is making notes, please write this thing in the copies or wherever you are noting down the point. Write down this thing. Thumb rule for the p-value. If p-value, I think I need to write on the Word file, that it would be easier for you to understand. Thumb rule. If p-value is less than 0.05, if I'm testing my hypothesis at 5% level of significance, so I will compare my p-value from the 0.05. So if it is less than 0.05, we will reject the null hypothesis or H0 or H0. Similarly, if P is greater than 0.05, we will accept the H0 or null hypothesis or H0. Done? Everyone has noted down this? These are the thumb rule.
Yes,
Yes, ma'am.
Yes. So now we are coming back to this particular output window. You can see here significant. Significant means the p-value. So always keep, or you can write there p-value or significant value, one in the same thing in SPSS. So we need to check the significant value is whether greater than 0.05 or less than 0.05. So I think it is
Less than.
less than
Less than.
0.05. Yes, thank you. So it is less than 0.05. That means we are going to reject the null hypothesis.
Null hypothesis.
Null hypothesis.
Reject.
Very good. Very good. Thank you, everyone. So here I am writing my null hypothesis for Shapiro-Wilks test. Shapiro-Wilks test, the null hypothesis is variable is normally distributed. This is our, I think it is visible or not in the online mode?
Visible, ma'am. Visible,
Okay.
ma'am.
Okay, thank you, ma'am. So you can write down the hypothesis of the Shapiro-Wilks test is that the variable is normally distributed. This is our null hypothesis. And according to the results of Shapiro-Wilks test, we can say this thing, we are going to reject the null hypothesis, and that way we are concluding that variable is not normally distributed. I think same thing we have concluded from the descriptive table also, right?
Yes, ma'am.
Now moving towards to the next thing. You can see the histogram. I think from the histogram also, if I will keep here the bell-shaped curve, it would be rightly skewed, right? Means here very less people who are getting the higher salary. So many people are at the lower side or lower tail. They are getting, means most of the employee of the organization are getting the salary which is coming very less, right?
Yes, ma'am.
So if I want to keep the bell-shaped curve on this, so what I need to do? You need to only double click on this area. Once you will double click on the area of the histogram, you would be able to open the chart editor. Is it open?
Yes,
Yes.
ma'am.
Now you can see here at the lower bar, you would be able to locate the distribution curve. I hope I am able to show you. I'm rotating my mouse, right?
Yes,
You
ma'am.
need
Yes,
to,
ma'am.
yeah, you need, yeah. Thank you everyone. You need to click on this only. Once you will click on this, then you need to only, whenever you will click on this, the properties window will open, and from this window you do not need to do anything. You need to only close this thing. So you need to close this thing. You can see it is already there. You need to close this also, and you would be able to see the bell-shaped curve here on the output window of your SPSS. So from this window, you can see the right tail is the greater than tail than to the left tail test, right? Right tail is
Yes,
more
ma'am.
greater than from the left tail. Yes. So that way I can conclude that this data is rightly skewed or positively skewed data. Here there are so very less people who are getting the higher salary, right?
Yes.
Yes, ma'am.
Yes. Now coming back to the QQ plot also. So from the QQ plot also you can see when the curve, when I have told you when this curve is going at the left hand side, so that way I can conclude this thing that the data is the positively skewed data. Now you can see most of the data points are going beyond this particular line, this fitted line. They are not following this fitted line. So that way I can conclude again on the basis of the QQ plot that data is not normally distributed for the salary variable, right?
Yes, ma'am.
Yeah. Lastly, I need to show you box plot. Yeah. I think you would be able to see box plot on my screen, right?
Yes.
Yes.
Now you can see this is the middle line, which is telling me the median value. I think it would be around 27, 28 something. From the table, I think we can see that this is the median value of the data. This is the first quartile. I think it is around 25,000 or below 25,000. This is the third quartile. This is the upper whisker and this is the lower whisker. And you can find out here, there are so many piled up circles and the asterisk sign you can see here, right? That means these are what? These are the outliers in the data. And outliers are at the which side? Right side of the data, because you can see here the histograms on which we have kept this particular bell-shaped curve. It is also showing saying me the same thing, right?
Yes, ma'am.
Yes. So here you can see there are so many outliers available in my data. So till the circle, means circles are the outliers which we can accommodate, which we can keep in the data. But these asterisks are the problematic thing. These are the significant outliers which can, what I can say, fiercely, immensely affect our results. So you need to take a call whether you want to keep these outliers in your data points or in your data set, or you want to drop it. So again, that would be your calls. That would be your discretion. How you are going to, whether you are keeping it, whether you are removing it from your data, you are dropping it from your data, that would be your call. But I'll tell you one more thing. Say for example, you can see this is the case number 29, which is the highest value. I think this is the person which is getting the highest salary. I think it is 1,35,000 something. right? I think here in the descriptives we have seen the highest value. Maximum value was 1,35,000, right?
Yes, ma'am.
So this is that particular value. This is the person, 29 number person is getting the highest salary. Now what you need to do, you need to come to the asterisk and you need to only right click here. So once you will click on the right, you would be able to see so many different things. If you want to, just a minute. I think rather than clicking on right, just a minute. You need to double click on that particular chart first. You need to double click on the chart. That is box plots. You would be landed to the chart editor. Are you? Everyone is on chart editor?
Yes, ma'am.
Now you
ma'am.
can, yes, now you can right click on the asterisk sign. Done?
Yes, ma'am.
Now you can see there is an option go to case. Is it visible to
Yes.
everyone? Click on
Yes.
that. Once you will click on that, the SPSS will highlight all the outliers of the data. You can see all the outliers are highlighted by SPSS. So now it's your call whether you want to drop them or you want to keep them in your data. Is it clear?
Yes, ma'am.
Yes. So I hope everyone is understanding how we can do all these exercises in SPSS. I think this
Yes,
was the
ma'am.
last thing, right? I think iske baad kuch nahi hai, nothing is there. Yeah. So I have explained you all the things. So I'll summarize, I'll conclude the day. Today I have discussed the reliability firstly, and then I have discussed the normality. In the reliability, I told you what is the meaning of reliability. We have seen we can go for the reliability testing for the continuous variable also and for the dichotomous scale variable also. There are certain methods available. In all those methods, the best one is, or generally most used one, I can say, most used one is the convex alpha value, through which we can check or test the reliability of the variable. Then I have told you the explanation of the alpha value. If we are getting alpha value 0.7 or greater than 0.7, we will accept it, or else we will say that our scale is not reliable scale. Then if alpha value is greater than 0.9, that is the indication that there is multi-collinearity in the variables or in the items of the particular data. So in that case, you need to find in which two items the high correlation is existing. So from that particular scale, either of the question you can drop. Clear? So this is what I have told you in the reliability. Then I told you how you can improve the reliability, that is the Cronbach alpha value. So you need to check upon whether there is any missing value available in your data or not. If there are so many missing values available for any particular data point or for any particular items, so you need to take a call whether you are dropping it out or whether you will go with it, or you are replacing those missing value with some particular value. So it would be totally your call. Then you need to check the mean and median, mean and standard deviation figures. You need to check whether there are certain items which are redundant in nature or which are ambiguous in nature. You need to check all these things. Then you need to check the item total correlation. If item total correlation is negative for any of the item, you will drop immediately those items from your questionnaire by writing this particular note that these items are carrying the negative item total correlation. So for the purpose, these questions were dropped out to improve the reliability coefficient. Then if still you are unable to improve your reliability coefficient, so in that case, now you will check the items whose item total correlation is less than 0.2. You will try to remove them. But you need to see this thing. You should have fair number of questions. With that, you will go to calculate or measure your construct. So this is what we have discussed in the reliability phase. Then we have moved to the normality. I told you for most of the parametric tests, we are bothered about the normal distribution of our variables. So we need to know firstly what are the characteristics or what are the features of normal distribution. So we should have, we can say that mean, median and mode should be equal. We can say skewness and kurtosis should be, usually it should be 0, but we can say if it is lies in between plus minus 2 and plus minus 3 respectively, in that case I can say that data is normally distributed. Apart from that, I have told you there are some other methods also which will tell us about the normal distribution of the data, and these methods are the Shapiro-Wilks test and the Kolmogorov-Smirnov method. These are the numeric method. In the graphical method, we can see the histogram, we can go for the box plot, we can go for the QQ plot. So I think all these things I have discussed today in the session. I have explained you with the help of examples. I have told you the interpretation part also. So this is all from my side for the day. If you have any queries, you can ask me. So I think, may I stop sharing my screen? If you have any queries, please ask me. The forum is open for the question answer now. I think, am I audible to everyone or not?
Yes, ma'am, audible.
Okay.
Ma'am, one basic doubt I have, being a fresher, I'm asking this doubt, like I don't have any knowledge about this interpretation. Like after collecting data, after collecting the questionnaire, so the first step with that raw data, what we have to do, like what you taught from the first step, we have to start doing that thing only, like we have to test reliability, then normality.
I think, ma'am, reliability you need to check first before checking the normality. I think normality is the second thing you need to do. Firstly, you need
Okay,
to check the normal reliability of your skill. I think maybe you have heard about the pilot study.
Yes, ma'am. Yes, ma'am.
So
Pilot
generally,
testing.
yes, generally what we do, we generally collect the data, or we collect the data from the, say for example, 30 to 50 respondents. And then we check firstly whether the scale is reliable one or not.
Okay, ma'am. Okay.
So you need to firstly check the reliability. Then according to whatever hypothesis you have created, then you need to check for those hypotheses. According to whatever tool you are going to apply, you need to then check for whatever test you are applying, what are the assumptions of those tests that you need to check. So for parametric tests, in almost each and every parametric test, you need to check the normality of your variables. So that you need to do then according to the tool you are using.
Okay, ma'am. And those tests which we used to apply after this, we have to do that, like F test, T test, what we are doing.
Ma'am, I think sabse pehle, or what I can say, the very first thing you need to check the reliability of your scale, because when your scale is not the reliable scale, not the stable or consistent scale, in that case, whatever you are, whatever you want to measure, you would not be able to do that thing.
Okay, ma'am.
And then
Okay.
you need to check upon your hypothesis which you have written, in your research paper or in your PhD thesis. So for that, whatever hypothesis you have written, accordingly you need to choose the test, and then you need to test the assumption of those particular tests.
Okay, ma'am. Okay. Ma'am. Thank you, ma'am.
Most welcome, ma'am. Anything else? So I think no more query for the day.
Yes, ma'am.
Okay, so thank you everyone for bearing with me. Thank you everyone for learning along with me and doing practice along with me. Thank you. Thank you, Ajay sir, and thank you everyone.
Thank you so
Thank you,
much, ma'am.
ma'am.
Thank you so much. Thank you all participants. Thank you, ma'am.
everyone.
Thank you, ma'am.
Good
Thank
day,
you.
ma'am.
Good day, everyone. Bye bye. Take care, all. So I think, may I leave the meeting, Ajay sir?
Yes, ma'am. Yes, ma'am. Thank you
Yes.
so much. Please.
Thank you so much, sir. Thank you.
Thank you, ma'am.
Most welcome, ma'am. Thank you, everyone. Thank you.
Thank you, ma'am.
Thank you, sir.